Right. Hi everyone, let me know if you can hear me. I'm hoping that you can see me. So I'm going to give it a couple of minutes before I start just to make sure that everyone is here. I think you might need to refresh the page, etc. Sometimes it seems to work, sometimes not so much. Let's see what's going on. I think I read all the comments. Oh, I missed this one. Hi everyone, stay safe. God bless you all. Yes, please don't catch any nasty viruses, etc. We don't like them. Shell. Hi, Shell. That's a nice picture. Loud and clear. Perfect. Awesome. So today I am going to, I have put together a presentation more or less. So I'm going to put some slides up on the screen so I won't be seeing the chat very much when I'm talking. So I suspect that it will take me maybe 25 minutes to go through everything. I don't know. Sometimes I just keep rambling on, I guess. So it's not super short today. So if you have questions, just ask them. I probably won't see them until the presentation's over. It's fine because I'm gonna scroll back and just go through everything, all the questions as usual. We'll see how many people turn up. Has been a little bit up and down with the attendance, so I think at the moment it says 13. We're usually around anywhere from 20 to 40. Don't know what's up with that. Patricia, hello everyone. Feeling better, Pim? Yes, thank you. I had a really mild cold, to be honest. I was totally down last Saturday, and that's why I didn't stream on Sunday morning, which is here. So your Friday last week, I literally spent the whole day on the sofa watching Netflix, feeling really bad. Had a super bad headache. Sunday was a bit meh. Monday I was fine. I could have gone to work if I had been allowed to. Obviously, with the lockdown, anyone who has any sort of symptoms is not allowed to go anywhere where they can meet people. So I had to stay at home. Didn't go back to work until Friday, but I felt great since then. And now I've given it to Mr. Bart, it seems, and he had the same kind of development of the disease as I had for 2-3 days, and then he on the third day he felt better, and then boom, worse again, and now he's on the second day of being not feeling great at all. So we shall see. Yes, I figured that, but it's funny anyway. Beep boop, Fapnado. Hi Shirley, nice to see you. I haven't seen you in a while, have I? Maybe you're just quiet. Hi Daniel, nice to see you too. So for those of you who just popped in, what I was just saying is that I'm going to go through, I have some slides that I have prepared for you. I'm going to go through that, and while I'm doing that, I probably won't see the chat, but feel free to ask any questions while I'm doing that, and I will get back to you. And by the way, I forgot to show this 2 weeks ago when I was talking about how to reset the immune system in 3 days. I have my own coronavirus, just so you know. They are super good. Anyway, break out the bleach. Yeah, we did do, I think I did most of it. House cleaning yesterday was not too much fun, but it's cleaner. Ah, a lurker. Well, I'm kind of a lurker myself. Sometimes I'm sitting in on Bart's streams or videos, and I don't say anything until I say something, and then everyone knows that I'm there. So I know how it feels. And today I have some egg coffee because you guys made me go and buy coffee, so now I'm drinking it every other day or so. Okay, so we'll remove that one and get some things happening here. So basically what I'm going to talk about today is that we're going to have a look at how the immune system works. So that's actually going to be the main part of this, because if you don't know how the immune system works, you're not really going to understand what I'm saying about sugar and its effect. Or I could just say it in 2 lines and we could be done here. You could all just go back to bed or whatever you were doing before you turned up. So rather than doing that, I'll just explain a little bit about how the immune system works and the different components of the immune system and how sugar affects those components. Don't get me wrong, the immune system is super complicated and we don't even know how it works in all the ways that it works. So what I'm going to tell you is it's going to be based on research, but I'm also going to simplify it a lot to make it somewhat understandable. Just so that you're aware of that. I mean, I'm a trained biomedical scientist. I do understand things when I'm reading them, but it can easily get really complicated even in my head when I'm trying to fit the bits and pieces together, because they have so many names, there's so many things that affect so many different things, etc. So if you're trying to draw a map of how things were affecting each other all over the place, you will probably have lines everywhere. So it's easy to just focus on a specific area, which is a little bit what I'm going to be doing today, just so that you know. So let me just share my screen. We're going to start with having a look at the white blood cells, because that's basically what the immune system is, I say. That's the main. Oh, I don't want to share that one. I want to share the other one. Where did it go? I want to share. Why is it not showing? There we go. So the white blood cells are this is pretty, when we talk about the immune system, we're pretty much talking about the white blood cells, but there's so many more things involved in the immune system. But the white blood cells are the ones that produce or stimulate production of other things that are involved in immunity. So I want you to kind of at least remember the first two for now while I'm talking. I'm going to remind you later on. But the vast majority of our white blood cells are neutrophils. So that these are the most common ones. We have on average 62% of the white blood cell count should be neutrophils. That's a normal value. Hey dog. And then we have 30% lymphocytes, 5.3% monocytes, and then we have some eosinophils and basophils, which basically they're not as many and they're not as important for what we're going to talk about today. And I'm going to tell you what their function is as well. So just remember the neutrophils, 62%, and the lymphocytes, 30%, so that we know pretty much what we're talking about. And neutrophils are the cells that fight bacteria and fungi. Okay, so that's their major role. What they're doing, they are pretty much the way they're functioning is that they are little Pac-Mans and they just eat bacteria or fungi that they come across. They die pretty quickly because they have a limited capacity of eating these bacteria or fungi. So they can eat a certain amount and eventually they're going to get full and they're going to die because they don't have the capacity of breaking down any more of these. And if you're looking at any site of infection, if you have cut yourself or whatever, that site of infection is going to be full of neutrophils, because these are obviously we have most of them and they're going to be there really quickly. And also if you have, let's say that you have a wound that hasn't quite healed or it gets infected, we say that it's getting infected, it's always infected, but when you get pus in it, the pus is basically dead neutrophils. So the more neutrophils you get there, the more dead neutrophils you're going to get, and the worse it's going to be. What do you want, dog? I'm not going to let you out. You're in here now. Sorry. I have a restless dog. So that's the neutrophils. They're quite handy. They're really good at fighting infection very quickly. And preventing any further infection. So if you cut yourself or get some sort of trauma. And then we have lymphocytes. So you might have heard of B cells, T cells, natural killer cells. These are all different types of lymphocytes. And what am I doing? There we go. And lymphocytes are quite interesting because they have so many different functions, and B cells, T cells, and natural killer cells, they're all functioning in different ways. I'm gonna have to let this dog out. I'm not sure what she's on about. Hang on. Just piss off. Don't come back. Sorry about that. That's not distracting at all. Okay, so as the name suggests, lymphocytes mainly resides in our lymph nodes, and all of the different kinds are residing there. They are maturing there. Some of them are developing, and they learn things. So it's pretty much like lymphocyte university a little bit. So if we have a look at the different kind of lymphocytes, so we have the B cells, which I'm simplifying now, but pretty much they are the adaptive immunity. They are the cells that will learn what pathogens look like, and they will create antibodies towards those pathogens, right? So those are the B cells. And I don't know if you can see the picture here. I don't know if you can see my mouse cursor, but the little blue oval things there, they are bacteria, and the red dots on those bacteria are the bacterial antigens. And antigens are just usually glycoproteins or something else on the cell surface of the bacteria. And these don't have the same structure as anything that is on our own cells. So when our immune cells come across these, they will recognize them as something foreign. And then when the B cells are learning how to create the antibodies, they will create something that attaches to these. So there's something that is complementary to them. And it will send them out. Some cells will be coated with antibodies, and that way they will be not very efficient at doing whatever they're doing, and they will die. Some antibodies coat them and bind to other cells that can then bind to these bacteria, poke little holes in them so that they die, etc. So there are many different mechanisms, but essentially what is happening is that the antibodies are binding to them and they die in some sort of way. And then we have T cells, and these are quite interesting cells. They have so many functions. There's so much research going on, and I think there will be for many, many years. I don't even think we are, understanding at all what's going on here. But we have two different types, main types. We have T helper cells and we have cytotoxic T cells. So you might have come across CD4 positive cells or CD8 positive cells. That's the same thing as T helper cells or cytotoxic ones. So they have a little bit of different functions. The T helper cells, as the name suggests, are helping. So they might be helping by releasing some other cytokines or something that will attract other immune cells, or helping in some way. They're coordinating the immune system. They might be shouting out to the other immune cells that, hey, there's a pathogen here that you need to take care of. And then we have the cytotoxic T cells. Cyto means cell, pretty much. So they are toxic to cells, and what they do is that they bind to cells and they basically toxify them. They kill them straight away. And then we have the natural killer cells, or the NK cells, that they work a little bit differently. So the cytotoxic T cells also fight viruses and tumors, but the natural killer cells might be better at it. And that is because, I'm going to try to not make it complicated. That is because all human cells have something that is called MHC1, which stands for Major Histocompatibility Complex 1. It's like a little marker on the cell membrane. All human cells have this, and if it doesn't have it, that is a signal for the natural killer cells to attack these cells. So that would make sense if we have bacteria coming in that don't have the MHC1 complex on them. However, viruses are always infecting the cell from the inside, so we won't see it. But one of the ways that our cells can protect themselves from viruses is that they are actually um, down-regulating the MHC1 complex so that they no longer carry this signal. And that in itself is a signal to the immune system that this cell is infected and it wants to get destroyed. And the same thing happens a lot of the time in tumor cells. And that's why the natural killer cells are there's a lot of research into these cells because they can be very useful in terms of fighting cancer, for example. They also release different kind of inflammatory cytokines, which then will attract other immune cells to come and help them, and that is called chemotaxis, just for your information. And then we have monocytes. I love these. They are quite cool. So first, when I learned about monocytes, I thought that they were pretty much functioning a little bit like neutrophils, because they do. They do eat bacteria, they do eat fungi, but they can also eat viruses if they can find them. So what they do is that they engulf these and then they chop them up into small little pieces. And they take these little pieces of the cell membrane from the bacteria or virus or whatever it is. It could be whatever. And they put it into their own cell membrane with a little signal saying, hey, look at this. This is something that is foreign. I want you to look for this. This is the description of the pathogen that we have. Now everyone go and attack this one. That's basically how they work, which is super cool. And they also teach the B cells, like, make antibodies towards this molecule, because this is what they look like. After they have circulated around in the blood for a while, they usually become tissue macrophages. And this is where they look a little bit like the neutrophils. So they can go out into our tissues and start destroying bacteria that might be in our tissues. But they also function as vacuum cleaners. So if you have had an infection and you have a lot of pus, for example, or dead tissue, whatever, they can come in and just clean it up, so that you know somehow magically pus usually disappears, and that is the monocytes that take care of that. And they are much more long-lived than the neutrophils, so that means that they can clear quite a lot of stuff before they die, so they can regenerate themselves. Okay. Then we have the two last ones, and I'm not going to talk a lot about them, but eosinophils are usually involved in allergies, and what I'm thinking about when I'm thinking about eosinophils is that they are the number one immune cell that is there to fight parasites. So, oh God, I keep doing that. So what they do is that parasites, if we talk about a parasite, let's say a hookworm or something, they are quite large because we can actually see them with our bare eyes. They, might be a couple of millimeters or whatever, whereas eosinophils are cells, so we can't see them with our eyes. What you see up in the corner there, the picture of an eosinophil, is just under the microscope, an electron microscope. So we can't really see them. So they're very, very tiny compared to the parasites. So we can't use anything like neutrophils or something to actually destroy parasites. So we need something else. So what they will do, that they secrete lots and lots of chemicals that will attack the parasites and therefore destroy them that way. And that's why they are usually in our mucous membrane. So we have them in our lungs, and we have them in our the whole respiratory tract, the digestive tract, the urinary tract, all of those kind of surfaces where we are more exposed to parasites or more likely to get parasites coming into our bodies. And the last one is basophils. These are the ones that are involved in allergies or sensitivities. So histamine is probably something that many of you know about. These are the major histamine-releasing cells that we have in our bodies. So when you get hay fever or something, it's usually your basophils that have been emptying themselves of histamine, and you will just get a reaction to that. So what histamine does is that it actually increases blood flow, and that will just let it will make the tissue more permeable to neutrophils and other blood cells that are coming in. So that helps to quickly get the immune system involved and get things happening to protect you from the danger, which is usually like pollen or whatever. So it's not actually dangerous, but somehow our immune systems think so. And then they also release heparin. And you might have heard of heparin, but more in medical terms. And heparin is a anticoagulant. So it basically will inhibit blood clotting at the site of where they are. So that will also allow the white blood cells to quickly move into the area. And there are some other chemicals as well that will attract eosinophils and neutrophils, etc. So, but we're not going to talk much about them because they're not very relevant for what we are going to talk about. So, just going to put a quick recap up here. So you should have like a basic understanding of how the different components of the immune system works now, I hope. And as you might have noticed, the neutrophils that make up 62% of the white blood cells are not fighting viruses. Okay? And I'm sure you right now are most interested in knowing how to fight viral infections rather than bacterial infections. I'm not saying that bacterial infections aren't important, because we do get a lot of bacterial infections. But if we are interested in strengthening our immunity in terms of protecting ourselves from the flu or the coronavirus or whatever, or any cold, we want to strengthen the part of the immune system that actually deals with viruses. And that will mainly be cytotoxic T cells and natural killer cells. Those are the main two, I would say. So now I'm actually going to take a quick break and have a look if you had any questions with regards to that, because you might have some specific questions. Okay. Let's see. Dum dum dum. Okay. So Necrokit in the house. Nesra. Bell works fine. Hello, flesh consumes. Oh my god, now my bloody dog is back opening the door. Sorry, I'm gonna have to close that door because I have the heater on in here and I'm cold. So are you done then? I'm not letting you out again. Okay. Oh, Shell is leaving. Thank you, Shell. I hope to see you later then. Gung Fu in the house. Good, thank you. Welcome. Hi, Elizabeth. Hi, Sea Runner. Hi, girls and boys. Sickling. The Plague Survivor. Okay, I can't see any real questions. Damn, am I late? What did I miss? I don't know what you missed, but I was just giving you a rundown on how the immune system works and what it actually consists of. So that's pretty much what I'm having up on the screen. So the neutrophils, which is 62% of our immune system, fights bacteria and fungi. Lymphocytes, BT and N natural killer cells. These are mainly involved in viruses and tumor cells, some bacteria as well. Monocytes, a little bit of everything. They act as neutrophils, but in a later stage, pretty much, and they're pretty cool because they help the antigen, or they present the antigens to the B cells so that they can start producing antibodies. And then we had the eosinophils and basophils, which we're not that interested in just today, but of course they are important, but we don't usually deal with so many parasites nowadays. Okay. So Bot K, I have a consultation question. Will you be live after Pim's live stream? Well, we shall see, I guess. Okay, so he says yes, he will be online. Cool. Kerinsky, you're a very good teacher, great slides and well explained. I've been absent for a few weeks, distracted by something else, and often asleep when you stream. Back now, thanks for your work. Well, thank you very much. I'm glad you like them. I'm not done yet. I'm just checking if you have any questions. Hi, Matt. Nesra, can you recommend an in-depth source or textbooks for more in-depth on immune mechanisms? I will have to look that one up for you. I'll find something for you. I'll probably find it for next week. I'm just gonna write it down here so I don't forget about it. Because you're usually here. Okay. Why does the histamine stuff get out of hand and cause the well-known problems? So are you talking about allergies now? That's literally something has gone wrong with the immune system. So an allergy like pollen, for example, or for me, I'm really allergic to cats and apparently guinea pigs as well, which I didn't know until I came into contact with a guinea pig and had a similar reaction to what I have with cats. I'm allergic to dogs, most dogs, not my dogs, thank God. And pollen. So there's something that has gone quite wrong in my immune system. So I think that these pollen or dandruff from the pets or whatever it is has come into contact with my system, and for some reason they think that they are pathogens rather than just innocent pollen, dandruff, whatever. And I actually don't think that, I mean, if someone knew exactly what it is and why it is, we could probably reverse it, but they don't. So there are people that say they have got rid of hay fever by going on a carnivore diet. Great, I'm happy for you. Obviously, I haven't been on a strict carnivore diet without any vegetables or anything for any period of time, so I can't say that I even tried it. Is it possible to reverse it? I never thought that it was possible to reverse it, but maybe it is. Maybe if people can see a reversal, maybe it is. But the thing is that we are getting antibodies towards them. So that's why. So when I got first noticed that I had an allergy to cats, what happened was that we were going to get a kitten. So we went to look at these kittens and nothing happened. I didn't get a reaction or anything. And then we went back a second time and we had a look at them again. Amy, stop it. Oh, I'm going to throw her out again. And then we went back the second time to have a look at these kittens. And within 10 minutes, I had a massive hay fever reaction. My eyes and my ears were itching, my nose were running. And the reason that I didn't get this response the first time is that it takes a while for your immune response to create antibodies. And that takes a week or two before you have a full response. So the second time I was there, I already had the antibodies to it. So my body was just attacking all of these dandruffy things. Are you going to steal my dog? Leave her. Just close the door properly. He's trying to help. And that's how it works. So the first time we come into contact with something, we don't even notice it. But clearly I was reacting to it the very first time. So it might be that you're stung by a bee one time and you don't react to it because you don't have time to do that. The second time, you might get an anaphylactic shock. So I can't tell you why that is because I don't actually think anyone knows why it goes wrong. And it's the same thing with autoimmunity. Autoimmunity is when your immune system attacks your own cells. So they might come into contact with, let's say, a pollen. It's usually not pollen. It's usually more like, let's say, something from wheat or cheese or whatever, or from other bacteria might actually just leak in through your gut because you have been eating a lot of wheat, which allows a lot of foreign particles to get into your blood system. So if you then come into contact with a piece of whatever that you shouldn't really come into contact with, even pollen, maybe I've been eating honey or whatever, and it gets in that way, your immune system can react to that. But might be that they have a very similar sequence on one of the molecules on the cell surface that is very, very similar to the molecules on your own body cells. And then your immune system is going to get confused and it's going to start attacking everything that looks very similar. And once it started attacking your own cells, it will create more antibodies that are more specific, that look exactly like, or they fit exactly to the antigen on your cell surface, so that you basically now you have the perfect response and your immune system is targeting your own cells, and very effectively, unfortunately. Pim, how risky would you say MCT oil oxidation would be compared to the commercial oils you did your aldehyde study on? I don't know. I mean, what I can say, the aldehyde study I did was on omega-3 fish oils, or fish oils, which has both omega-3 and omega-6s in. So the more unsaturated fat is, the more prone to oxidation it will be. And omega-3 is much more prone to oxidation than omega-6s. And that is because the 6 and the 3, so if a fat is saturated, all fats consist of a carbon chain. All the carbons have hydrogens attached to them, and there's nothing that can be going on there. If it's unsaturated, it has a double bond, so there's 2 bonds between the different carbon molecules. And these bonds don't really want to be paired to the carbons. They would rather bind to something else. So if an oxygen comes in there, that's where it's going to oxidize it. But so omega-3 means that the double bond is located on the 3rd carbon from the end, and omega-6 means that it's located on the 6th carbon from the end. And the lower the number, the further out to the end it is, and the easier it's going to be to oxidize that. So it totally depends on if you have many double bonds, which is, if you have a monounsaturated fat, you have 1 double bond. If you have a polyunsaturated fat, you have several double bonds. But the bonds that are most likely to be oxidized first are the ones that are further out most of the time. So even like an omega-3 rich oil is going to be more prone to oxidation than one that is omega-6 rich. It's going to take a bit longer, it's going to preserve a bit longer. So from that standpoint, omega-6 is better, if you want to say better, but it's not better to consume. It's just less prone to oxidation than omega-3s, etc. And then you just wander up there. So it totally depends on the structure. And medium chain triglycerides, they're quite short, they're quite stable. I don't think you have to worry too much about it, but I don't have any data on that. I don't have any research done on it, so I can put it on my list to see if I can find something on that. And if I do, I will let you know next weekend when I go live. Okay. Nesra, much appreciated. Did you get my paprikas recipe I sent you? Yes, I did, and I forgot to reply to you. Sorry, because I haven't made it yet. I just left it there, and I don't even think I opened the email so that I would see that it was there, and then I forgot it anyway. Okay. So these neutrophils, lymphocytes, etc., are always present whenever there is inflammation. Yes, they're always present non-stop. We always have some inflammation going on. But this is basically when you go to the hospital and you ask for a full blood cell count, you will get a report back that says you have this much of this and this much of that, and you're either with or within the range or not. If you have a neutrophil count that is way above where you would normally be, you probably have some very acute inflammation going on, etc. If you have a lot of basophils, then you might have an allergic thing going on that is, a chronic allergic reaction to something. So that's how we can see that things might not be quite right when you do a white blood cell count. Matt, I just fell off my chair when you said my name. Goddamn woman, you drive me wild. Matt, you're funny. I say your name again. Matt, Matt, Matt. Vegetables, hand in your card, miss. Oi, I made some bolognese the other day with onions and garlic and smoked paprika, and who ate it? Not just me. Just saying. Which of these attack our body if we have an autoimmune issue? So an autoimmune issue, I think I covered that a little bit. So your B cells will produce antibodies towards it. Your natural killer cells will also attack your potentially attack your own tissue. Your T cells would probably be involved in that as well. And I think there's not so much neutrophils because they will just not be too worried. You shouldn't be too worried about those. So I would say it's mostly the lymphocytes involved in that. I remember a couple of weeks after I started keto, my seasonal allergy almost completely disappeared and I was able to breathe well. This one of the many reasons I still stay low carb, high fat. That's awesome. I'm really jealous. I still haven't. I mean, I've been low carb for many years, and that hasn't taken care of my allergies for sure. I have that problem too. I don't always react straight away or right away. Now, everyone has that problem. We shouldn't do because the first time you come into contact with something, you wouldn't really necessarily notice that. Richard has the same thing as me. Still hay fever, even though carnivore. Nesra. I have one allergy and it's weird, not sure what it is exactly. When I dig around in a specific kind of dirt, I get a rash similar to insect stings and it's extremely itchy. That's funny that you say that. Because yesterday, or no, 2 days ago, when I made that bolognese, I was out. We have like strawberries growing out there, and the previous tenant has probably had like a herb garden there, so they have some thyme growing under there, and it grows really well under all of the strawberry leaves. So I was out to pick some thyme, and then I got in, and I just got like a rash all over my arm. And I get that if I'm laying on the lawn usually, so I thought it's because I'm allergic to grass, but it's something in there as well that I'm clearly not handling very well. That was a very clear and detailed answer, was it? I can't even remember what did I answer your question that clear? Okay, I'm glad you think so. Anyway, I can't remember what it was. Might be some kind of fungus. There are lots of them in the soil. Yeah, sure. Okay. Okay, so that means I can continue with the presentation. So I haven't actually popped out of that, but I'm going to pop it up back on my screen. So now when you know how that works, hopefully you kind of got this into your head that it's neutrophils and lymphocytes that we are majorly interested in. So let's have a look at what sugar actually does, because that's what I was going to talk about. So this is quite funny because in the 70s, there were several studies done on sugar and the immune system. And there's pretty much been not much going around after that. Maybe because we started blaming fat for everything. So no one thought that, we're not really interested in researching sugar anymore. We just want to look at fat. Could have been. Or, there was no funding to look at that sort of thing anymore. I have no idea. But anyway, a lot of research from the 70s anyway they undoubtedly show that sugar reduces the phagocytic capacity of the neutrophils in humans. And now neutrophils, those are the ones that we have 62% of. Those are the ones that attack bacteria and fungi, but they're not involved with viruses whatsoever. Okay? So what they saw that this effect is actually present straight away after we eat sugar. And they measured up to 5 hours. And after 5 hours, they still had a reduced effect. Okay. They peaked somewhere between 1 and 2 hours with being pretty much sedated. where they couldn't fight anything. They just, almost like drunk ones. Um, but the interesting thing here is that they saw this with sugar. So 100 grams of something like they had glucose, they had fructose, they had sucrose, honey, and orange juice. They tested all of those, with all had the same effect. But when they tested with starches, it actually didn't have this effect. So that's quite interesting. So it's just sugar, not actually starch. So it doesn't actually reduce the number of neutrophils. It just makes them useless. It prevents them from doing what they're supposed to be doing. So that's quite interesting. And you don't see this effect if you're eating fat or protein, okay? So that's pretty good to know. So we can eat fat and protein, and we still have normal neutrophil capacity and functionality. Right, so if you're fasting though, that will increase. So this is good. That will increase the phagocytic activity in the neutrophils that you have. So if you were here 2 weeks ago when I was talking about resetting the immune system and that you needed pretty much roughly 3 days to start get the effect and rebuild your immune system by literally over the 3 days breaking down the old immune cells, etc., and that we are getting decreased numbers of immune cells during the fast, and therefore we might be a little bit immunocompromised. But when you're fasting, the efficiency of these cells actually increase. So I don't know how much of the loss of numbers this can make up for, but there seems to be some sort of compensatory effect there, which is quite interesting. So that's a good one to know. But also keep in mind that the actual number of cells do decrease when you're fasting. But that's probably fine. And once you're done fasting, you get the beautiful effect of just regenerating all those new cells into really healthy and well-functioning cells. So if this is your baseline, you go down in numbers, but your efficiency might still be quite high, and then you go up in both efficiency and numbers when you're done fasting. So you might have heard the expression feed a cold, starve a fever, maybe, or maybe not. Basically what this means is that a cold is always caused by a virus. Okay, so when you have a viral infection, you should not be fasting, you should be eating, and that way you're fighting the cold and you're fighting the virus. Starve a fever, literally, if the fever is caused by bacteria, that might work, but if it's caused by a virus, that won't work. So that's a little bit misleading, but there is some truth to it if we can see that feed a cold as being a virus and starve a fever as being bacteria. So what we have seen, if we are looking at mice, because we love looking at mice, is that mice that actually eat, let's see if we can see here. So mice that eat when they're, okay, you have a group of mice, and when they are infected with a bacterial infection, they will naturally not eat as much. When these mice are being force-fed, what happens is that the mortality in these mice increases massively. Okay? When this is a starving mouse down to the left, by the way. I couldn't find a good picture, so that's kind of a starving mouse. When they are allowed to not eat as much, they survive to a much higher degree. So this is when they have a bacterial infection, okay? When they have a viral infection, it's the opposite. So when they're force-feeding mice that have a viral infection, they tend to survive to a much higher degree than when they're allowed to not eat as they would naturally do. So this shows us that in mice, anyway, when we are eating with a viral infection, we actually somehow increases our survivability. But when we are fasting with a bacterial infection, we are actually doing ourselves some good there. So this is obviously mice, but there is a very, very small study done in humans in 2002. And what that shows is, so at the top here, I'm going to explain what these numbers and things mean in a second. At the top, that means when we are eating, and the bottom is fasting, because that's just water. So they had a small study. These were 6 men. That's how many it was, but this is just what I was looking at. So when these 6 men were eating compared to baseline, which was like after an overnight fasting and whatever, their interferon gamma increased with 450%. And the interleukin 4 increased with 142% after eating. And I think this was 6 hours after eating. Everything was 6 hours, 6 people. And with regards to the fasting, interferon gamma decreased to 83% as compared to baseline, but the interleukin 4 increased to 398%. So, what does this actually mean? Because this is just probably words to many of you, and that's fine. So, what we can see basically is that when we are eating something, they were eating, I think I have it written down somewhere. So they had a drink containing 40 grams of protein, 144 grams of carbs, and 88 grams of fat. So there was a mix of macronutrients. It wasn't just sugar or just anything else. It was a mix. And what this shows is that when we're eating food, we are basically favoring cell-mediated immunity, which is where the T cells and the natural killer cells produce and releases interferon gamma, because those are the major cells that release interferon gamma. And as we were talking about earlier, viral infections, the cells that we need to fight viral infections are toxic T cells and natural killer cells. So this shows us that the activity of those cells are just going up massively when we're eating as compared to when we're fasting. Because when we're fasting, it went down to 83% of just an overnight fast. So clearly, when we're not eating, their activity is going down. So if we have a viral infection, it might be really good for you to eat. However, the interleukin 4 is totally different kind and is doing different things in your body. And it has more to do with the aspects of the immune system, the things that are floating around in your blood, if you like. So that would be complement or antibodies, that sort of thing that just assists the immune system. So it's not the actual white blood cells that are being so much affected by that. So IL-4 interleukin 4 is a cytokine that induces differentiation in T helper cells and B cells. So it kind of helps stimulating and maybe enhances the production of antibodies, maybe speeds that up a bit. I'm not really sure. It kind of just popped up now whether this, would have anything to do with the efficiency of mounting a secondary immune response, which is when we have produced the antibodies. I don't think so, because when we're eating, we're still getting an increase in interleukin 4. It's just not as high. And do we need? Sometimes it's good to get a quick response, because then we are getting immune quicker. But is it necessary? Most of the time, I don't think so. So I don't see that as a downside. That is just 142% increase as opposed to 398. So basically what's happening is that sugar decreases neutrophil activity. And that means that when you're consuming sugar, you're at an increased risk of a bacterial infection or a fungal infection. Fasting increases the rate at which we develop our secondary response, maybe, the antibodies, and it also increases the efficiency of our neutrophils. So that is a good thing. And Eating, I didn't even write eating down there. It should say eating increases capacity of the cytotoxic T cells and the natural killer cells. And this is what we want when we have a viral infection. Now, so I'm going to repeat what I said a couple of weeks ago on my live stream. Fasting is great to regenerate your immune system and to make sure that all your immune cells are up to scratch, they're functioning well, and they're fresh and performs the tasks the way that they're supposed to do it. And this can actually help with autoimmune conditions as well. However, if you are currently dealing with a viral infection, if you're currently down with a cold or the flu, or you are, you have to go out shopping and everyone around you has corona and you're scared of getting it and you think maybe I got infected, you shouldn't be fasting. That's probably not the best strategy. You should be eating. Now she wants to go out again. I'm going to ignore her. So the problem with this is that we don't really know when we have a viral infection, do we? Not until it's well underway, when we start getting symptoms. Then we can probably figure out whether we have a bacterial infection or a viral infection. So does that mean that we never want to fast? I'm gonna stop sharing, by the way. Amy, can you piss off? Go bed. 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 Jeez. No, I'm not letting you out. Okay, so where was I? I don't think that we should avoid fasting, but I still think fasting is great, and I think it's a really, really good tool that everyone, probably almost everyone, should be using to some degree. And if we're not doing longer fasts, then maybe, the 24-hour fasts. Does anyone want a dog? I have one for free. Come here then. Sit here. Come, hop. And so, where was I? I have some notes here to kind of keep me on track, and still I'm getting totally sidetracked by dogs. So I think everyone should be fasting if you can fast, or at least, try to do OMAD or 2MAD or whatever it is, because all of those are helpful, even though they might not mount the same sort of immune regeneration as you do after 3 days. Right now, if you are lucky enough to be in self-isolation at home, go for it. You have no, nothing to fear. You with, do it. That's probably a really, really good thing. But if you are like me and you might have to go to work and spend time with other people, etc., and there is a lot of corona going on, which there isn't really here yet, I don't think, then maybe it's not the best idea to do that right now. Maybe do it over the weekend when you can actually isolate yourself from other people. So to go back to my initial question about how sugar affects the immune system, it seems to have a major impact on our ability to, fight fungi and bacteria, but maybe not so much when it comes to viruses. And does that mean that sugar is free for all and we can eat as much as we like if we don't care about the bacteria or the fungal infections? I don't really think so. So if you're looking at people with diabetes, for example, diabetics are much, much more prone to suffer from severe influenza and then non-diabetics. And when they get the flu, they often get pneumonia. And they, unfortunately, a large proportion compared to the non-diabetic population also die from the flu that have diabetes. Is that because they're hyperinsulinemic? Is it because they are high blood sugar? I don't know. More studies have been done on the high blood sugar than the actual high insulin, but I'm wondering which is what. So hypoglycemia in itself can reduce neutrophil degranulation, for example, and it can also impair the complement activation. I'm not going to go into that because there's also quite, this whole cascade of things that are happening that will take out the pathogens. And it can also decrease the ability of your cells to engulf other pathogens. And that could potentially affect both viral and bacterial infections. So when you have elevated blood glucose, the glucose concentration in your airway secretions also increases, and this is quite interesting. So when you have the flu, because that is a respiratory tract infection, and you are hyperglycemic and you get extra glucose in your lung mucus that you produce, the flu virus seems to be, first of all, attaching better, and then it seems to be replicating much faster and making it more virulent or more severe. So you get sicker when you actually have high blood sugar. And I can't say for sure that this would be the case with something like COVID-19, but it's a virus, it's a respiratory tract form of virus. It's not the same as a flu virus, but they have similarities, and they obviously work in similar ways because they can attach to your lung tissues, and that's where they cause most of the infection. And I'm sure that they are taking advantage of the same sort of mechanisms. So I would suspect that having high blood sugar could absolutely make you more prone to severe disease when you get infected with a virus. They have done studies on patients who had the avian influenza, the bird flu, and that has also shown that hyperglycemia is very, very strongly associated with a fatal outcome. So why is that? It seems to be something, whether that is the insulin or just the blood sugar, or it's a combination of both, or maybe something else that diabetics or hyperglycemics have. So unfortunately, there aren't too many studies on hyperglycemia and viral infections in general, but as far as it goes, I suspect that increased blood glucose definitely isn't good for anything. Now, with regards to insulin, I managed to find one study from 2018 that found that viral-induced inflammation lead to insulin resistance in itself in skeletal muscle. And that makes sense because if we need energy to fight a virus, we don't want our muscles to actually use any of the glucose that we have in our blood. So that is a normal mechanism, and it should be there. The problem is that it also triggers, by doing this, it will triggering insulin production, and you will get hyperinsulinemia. And that will help T cells to do their job, which is good, I suppose. But in normal people, that's all well and good, but in people who are pre-diabetic, they might, after having an infection, a viral infection, they might be much worse off because they will remain in a pre-diabetic state, or a state of sustained glucose intolerance, maybe forever, maybe for a very long period of time, but it seems to be doing a lot of damage, which is quite interesting. This is pretty much the reverse of what we've been talking about, but I found that very interesting. So I think that there might be some interesting stuff with insulin and viruses as well going on. So if you're like me and you have, a well-functioning blood glucose system, everything works, you don't have hyperglycemia, you don't have hyperinsulinemia, you might get away with eating sugar when you have a viral infection and might be fine, but not so much from a bacterial perspective. So I would probably still tell you to, don't eat a lot of sugar. It's obviously not good. Whether we have any evidence for the impairment of that part of the immune system that is involved in viral infections or not isn't really that important. I don't think that eating pure sugar is ever going to be good. Maybe, I'm saying maybe, just maybe, a little bit of carbohydrates could be, beneficial when we have viral infection. Maybe. I don't really know. But, if you do it, make it clean, keep eating very nutrient-dense foods, eat, eat good stuff. I can have my blueberries, which I have anyway. But that sort of thing. Try to not, go for the ice cream and the soda and the crisps and the donuts and whatever. Try to do something that is actually, real food. So I don't think we know enough yet about everything. So I would rather be safe than sorry. And yes, now I've been talking for an hour, even though I did answer some questions, but I think that that's pretty much all I wanted to say. I think I can turn my light off because the sun has come out. And I'm going to have a look at what other questions are there right now. And having said that, just to let you know, if you want to support the stream, etc., you can always make donations to this Streamlabs here, or you can obviously super chat. And if anyone has done so while I've been talking, I will thank you in a second. But I can't see those right now. So let me scroll up and try to find where we were. Seeing that. Okay. I was telling on Bart eating bolognese with onions and garlic and smoked paprika, so he's been a naughty boy. You were never really carnivore. Where do I send my card? Yes. Carnivore is such an interesting term because, this is a carnivore. She's eating raw meat and bones and organs, like a real carnivore, but she's for certain, a opportunistic war. She will eat anything that comes in her way. And I think humans are pretty much the same. Okay. Okay, let's see what Fapnado has to say. With regards to the immune system resetting around 72 hours fasted, what if one continues to fast for days or weeks past that point? How does it behave? Does it keep resetting every 3 to 4 days? No, it doesn't. So the reset, okay, so when you are fasting, your body always has a need for a certain amount of amino acids to keep their functions going. So in the beginning, you will start breaking down things that you don't need anymore. So that might be cells that are not functioning well, which you probably have a lot of those immune cells that are not functioning well. And if they're not functioning well, they will be broken down, preferably to the ones that are functioning well. You will have old cells that are sluggish and they might not be functioning well either, and those will be broken down. So these are broken down so that your body constantly have a supply of amino acids for the things that are important, so that it can build up those cells that it needs and have cells that can perform the functions that you need to do on a daily basis to survive. So that's why that is happening. And 72 hours is nothing. It has just started. I mean, there's always a degree of it going on, but you pretty much, that's where you've got to a point where your growth hormone has gone up so much and your hormones has changed maximally. So so when you are refeeding and you give your body a lot of new amino acids and things to build up new cells and replenish those that have been gone, your body is just on high alert and it has all those hormones and everything going, and it's just like, wow, okay, we finally have energy. Now we're going to rebuild everything and we're going to make it stronger. So we're going to be strong. It's almost the same as when you're going to the gym. When you go to the gym, you break down your muscles and then you rebuild them, but you rebuild them slightly stronger than they were before, and that's how you're getting stronger. And that's how you can also strengthen your immune system. So if you're fasting for a month, you're going to keep breaking it down, but only to a point, because you will still need to have some immune cells. So your body will decide where that threshold is. At some point, your body is going to be like, no, we can't get rid of more, because if you are now cutting yourself on a knife or something, you get an infection, you might die from that infection if you don't have enough immune cells. So at some point, you are going to start breaking down muscle cells, but that's going to be quite far down the priority list. It will take all those old cells, and what you see is often like organ shrinkage. So it's not that the cells themselves are breaking down. So if, let's say your liver is built up of 2 billion cells, you're not going to see that you all of a sudden have a liver of 1 billion cells. It's not going to destroy those liver cells, but what it's going to do is that it might start downregulating the production of different organelles, and it will shrink those cells so that they're still functional, but they won't have excess of other things in them that you might normally think that you should be having because they might be needed. So at some point you start going to tap in and break down the muscles, because at some point your body's going to be like, okay, we had enough of that. Actually, I need all of these things. Now, what's my priority? It's not muscle anymore because I need to survive. So, I don't know what time frame that happens at. It's probably like a gradual increase, but that's pretty much how it is. So the reset is happening when you're refeeding, when you can give your body lots of new nutrients. That's when you are building it up again. Thank you so much for the super chat, Kerinsky. Can you please explain what a cytokine storm is? A cytokine storm. So that's really hard to. There's so many different cytokines, but usually I think what you are thinking about is that if maybe get rid of a dog and get some coffee. Cold coffee. So when you have an immune response, so the immune system is super complicated, and that's why I didn't want to go into that. But all the immune cells can release different kind of chemicals. And these chemicals, some of them are called cytokines. So a cytokine might be something that let's say that your natural killer cells releases a cytokine of some kind. Then that cytokine will go out in your bloodstream, and it will signal to, let's say, your monocytes that, hey, something's going on. This is where you want to go, and that's called chemotaxis. So your monocytes are going to be alerted, and they're going to go towards a higher concentration of that cytokine to perform their duty, basically. But a cytokine, when you say, I've never heard the term cytokine storm, but there could be a long chain of events as well. It could be that a cell is releasing one type of cytokine, but nothing is going to happen unless you have another type of cytokine that it can react with. So that is another way of kind of foolproof the system. So it's really complex, and it's so different in all different kinds of situations that I'm not really, it's just a cascade of things that is happening. Sometimes it's very short, sometimes it's really long, and it involves several different ones. So when I say you need 2 to activate something, maybe you need 5 of them to activate something. Maybe you need 5 different cytokines to come together to a complex, and that complex might bind to another immune cell. And when it does that, it will activate that immune cell. So there's so many things that can be going on there. So I'm not really sure how to answer that question, because it's very complicated and very specific to different kind of situations. So I hope that I managed to answer that somewhat okay, and that if you have a more specific question, just post that again. I'll try to answer that better. Let's see. Now I had to scroll up again. Okay. Pim Johnson, increasing fat or protein, or both for upping feeding during illness? Better. I'm just gonna pull the curtains because it's getting a little bit sunny on my face. During illness, so what sort of illness are we talking about? Again, if it's a viral illness, then you probably want to make sure that you get enough proteins. But as I said, there might be that during a viral infection, maybe it could actually be beneficial to add some carbohydrates, maybe. If it's a bacterial infection, eating proteins will obviously prevent any sort of autophagy, etc. I know that some people have suggested that maybe a protein fast, which means that you're not eating protein during a bacterial infection, might be beneficial. So during a viral infection, I would just make sure that I'm eating, nutrient-dense food, probably the same thing as I'm eating normally. If you think that you might benefit from some carbs, then I would just add that on top of, excuse me, hiccups. Am I still craving sugar? Yes, on and off, absolutely. I'm not free from that yet. I can go periods when I'm doing really well and I'm thinking, oh, finally got it. And then all of a sudden, boom, I need sugar. And it's interesting because sometimes during my period, I really want sugar. Sometimes I'm just really hungry. And that's interesting. And I wish I was just really hungry all the time. Not all the time as in every day, but every month. Think that going liquid could be a good tool during an illness, like soup or beef shake with eggs. Maybe. Are you thinking about, if you are drinking something nutritious rather than eating it, you will save a lot of energy because you don't have to digest it. It's usually kind of pre-digested and it's easy for your body to just take it up quickly. So maybe from that standpoint, it could be, absolutely. If it's a major benefit, I don't know. I couldn't really say. But, chicken soup is known for being good for colds, isn't it? Okay, we're talking about cardboard. So for me, I did notice that my immunity declines when I quit sugar. I don't know why, even though I totally believe it's unhealthy. Yes, okay. So this is very, very interesting because I have noticed that before in the past, like many years ago, that whenever I quit sugar, I tend to all of a sudden get a sore throat or something else. And I think that is just the change in metabolism and that my metabolism isn't working optimally because I'm used to running on so much sugar. And then all of a sudden I'm not eating sugar and my metabolism has to change and everything has to change. And you're not providing the right energy straight away. You need to give your body time to adapt to it before your immune cells or any system in your body will adapt to this new circumstance. So if this is in the realm of like a month after quitting, I would probably say that that's probably the reason. If that is the case, like after 6 months or whatever, then there's probably a different reason for it. But I have seen that myself, but I don't think I ever quit it for, I had quit it for a month, maybe, and a little bit more in the past when that's happened. But it usually happens, within a week or two after quitting that I got sore throat or something like that. I could usually sleep it off. No, I haven't had a sore throat in I don't know how many years, but it usually worked then. Poor Amy. Amy's a science denier. I don't know what's wrong with that dog today. I thought she needed to go out and then she came back in and then she wants to go out. Anyway. Necrokit says, I'm at the grocery store right now. People are scared of me and they shouldn't be. I've been indoors for a long time now. Yeah. It's still very crazy. Do we know how quickly the immune system rebuilds after the end of a fast? Steve, I would say that that happens really, really quickly because all of your hormones are just optimized for rebuilding. So they pretty much they have their orders already. They're just on standby. They don't have anything to build it with. So as soon as you start eating, that will happen very quickly. So I would say give it 24 hours and you're good. It might happen quicker than that, but depending on, what you're eating, how much you're eating, and the quality of what you're eating. Would reduced caloric intake have a significant effect on bacterial fungal infections then, or is it only fasting? Um, I think that so these studies from the 70s, they only saw this effect with sugar in your diet. So as long as you're not eating sugar, you should be good. But having said that, a reduction in caloric intake. God, I'm losing my voice. As in, like, a fasting mimicking diet or something, obviously has a good effect as well. Upton Sinclair wrote the book on fasting. I found a newspaper clip from early 20th century where they claimed a fast of less than 24 hours killed someone. Okay. That sounds like bullshit to me. Unless that was a type 1 diabetic or something who took insulin, I really don't see that happening. Could it kill someone? It probably could under the right or the wrong conditions, but there has to be some underlying medical condition there. That's not just going to happen. I have a blueberry bias for sure. I sure do. It's just that I like blueberries. They sometimes they're not. I was gonna say they're consistent, but sometimes they're actually very sour. But when you get sour like raspberries or something, they're horrible. And then I couldn't eat them without sugar. So I can eat blueberries without sugar any time. And they're easy to buy. But I like more things than blueberries. Oh, I only just saw your super chat button when you mentioned it. Wow. Yes. And once again, thank you so much for the super chat. Troy, how are you, Troy? Have you been lurking or did you just turn up? Okay, so I'm glad my answer makes sense about the cytokines. And I'm very sorry that I can't give you a very straightforward answer. It's just really, really complicated. I love immunity. It's actually I love biochemistry in general, but immunity is just one of those things I found really fascinating and really interesting. But it's so confusing, and when you think that you got it, you just got the basics, and then there's so much on top of that. So I'm not an immunologist. It would be pretty cool to do that if someone said, "Yeah, well, do you want to do a PhD in this?" I would actually think about it, but I'm always saying that I don't want to do a PhD, but it's something that would be interesting. Uh, Dust mites. Okay, let's not talk about dust mites. I don't know what to say about them. Cytokine storm. There's a video on YouTube about a first in human study using TGN 1412 that I think caused a storm and killed a fair amount of the test subject. Okay, so there might be something like, okay, so that rings another bell. So when you have like toxic shock syndrome, so when this is something that happens with women who forgot their tampons in or whatever, and they get an infection, they're not dying from the bacteria or anything. God. What they die from is that they get such a huge immune response with a lot of immune cells, and everything is just getting released. So you basically poisoning yourself and you die from this response. So if that was maybe what you were thinking about. Okay. Thank you, Troy. You're a sweetheart. I've been gaining a lot of muscle, haven't fasted in weeks. Been interesting experiment going from fasting every day, lifting 6 days a week in lockdown. Okay, so you haven't fasted in weeks and you've been gaining a lot of muscle since you stopped fasting, or just in general? Actually, I said this a couple of weeks ago that I'm gonna make a video. I might do it for the next live stream next week on fasting and growth hormone because that's quite fascinating. I was doing a lot of, I say pull-ups because I still can't do pull-ups, but I was doing a lot of crash downs yesterday, and today my biceps are really sore. So we all do what we can at home. 22 Mononoke. Just recovered from a high fever, sore throat, and diarrhea. Not sure if it was the coronavirus, but still haven't regained my sense of smell or taste. I mean, that sounds like pretty much all the symptoms that you could get from the coronavirus. So I don't know. Why haven't you got tested? Maybe you should. Amy saw ghost dying spirit everywhere. Okay, is that what it was? Aha, Troy is a lurker. Okay, so you put a lot of muscle on since you stopped. Okay, so that's interesting. I'll put this one up again. So I think so when you're fasting, your growth hormone will go up, but obviously it depends on the refeed. And last time I spoke to you, we were talking about that you were actually not maybe not eating enough calories. So I think maybe what's going on in your case is that maybe you fasted too much and didn't eat enough. And if you now have seen a lot of muscle gain in 6 weeks when you stop fasting, what I would do next if I was you is that I would try to do some fasting, maybe, up to 3 days, maybe 2 days, just to get your growth hormone going, and then have a big workout and a big refeed and see what's happening with that because that should actually, um, spur it on even more. But that's cool to see. Nesra, with the liquid stuff, when you are sick, sometimes you have no appetite, like food poisoning. Yeah. So liquid nutrients could help with that. In the ICU, you get IV glucose and vitamins, right? So food poisoning is most of the time bacteria. So you don't actually need to eat. It's probably better to not eat if you have food poisoning because when you have food poisoning, you have bacteria in your gut somewhere, whether that be in your actual stomach or in your intestines. If you start refeeding too soon and they're still upset, and you might actually be feeding the bacteria even, so you could just make it worse for yourself. I wouldn't necessarily say that you need to do that, but if it's so bad that you would go to ICU to get an IV glucose and vitamins, obviously you'll probably be in hospital. But if you think that is really bad and you don't have any energy, sure, have some liquid glucose, tiny amount if you must. But I would probably say that I probably wouldn't bother. I'll probably just do water for a while and recover and then go back to eating. So this is a summary at Kerinsky. Excessive or uncontrolled levels of cytokines are released when then activate more immune cells, resulting in hyperinflammation. Yeah, so that's pretty much summarizes the toxic shock syndrome that I was talking about. They're not testing anyone in the UK unless you're in super serious bad condition, i.e. having respiratory problems. Okay. Yeah, I think they stopped doing that in Sweden as well a long time ago because they realized that the flu season was going and they wouldn't be able to test everyone. So they just gave up on that, I think. Okay. I would probably, I mean, my best guess would be that, if you have all of those symptoms, you probably have it or had it. So congratulations, you survived. Now you don't have to be scared of everyone. Okay. You know what? Yesterday, I'm wondering if I can find that email. I got an email sent to me. I got so many emails on this bloody email. So yesterday, I might have deleted it actually. I'll see. But there was some UK company sending me an email saying that, oh, now you have the Corona home test kit, so we can send it to you. You only have to pay us 150 pounds, and we'll send you a home test kit, and then we'll show you if you have immunity to it or if you are having it, unless you're in the early stages, because then you wouldn't be able to see it. 150 bloody pounds to do a home test kit to see if that is what you have or what you have had. I think that was a private GP of some sort, and I think they are pretty much taking the piss and using people who are scared of the coronavirus. Yes, it is handy to know if you are immune. If you're immune, obviously, you should be able to walk around outside without being scared of actually getting it from someone else. However, who knows? If it's mutating, you might be able to get it again. Now, I don't think it is, but it might. Scammers. Actually, I don't think they were scammers. I think that was I think it was a genuine GP practice. I didn't actually check the link. Now I'm getting more and more curious. It's just that they have come across this and they see this opportunity to make some money, and not just some money, some pretty good money, I would say, if they're going to charge you 150. Oh, here we go. Let's see. I'm going to click this, order the test kits. Okay, so let's share this just for fun. Where's my share screen? So this is what I got. So this is called private GP. So if you suspect that you may have COVID-19, stay home, blah, blah, blah. Do not go to a GP's for blah. Okay, our practice is located in a quiet residential area in Leicester. That's where I used to live, so I might have been there. I don't know. I don't think I've been to a private GP. But anyway, so this is pretty legit. They are actually there. They don't mention the fee here. They do mention it in the email, though. I wonder if they put it up here. So just for fun. No, they don't have it there. That's strange. Anyway, they clearly, I think I contacted them at one point, and I think I know what that was about, but that wasn't to actually get treated by them. But anyway, I'm going to stop sharing that and go back to the main screen. So, everyone will take the opportunity of trying to get some money of people when they can. And I mean, everyone needs to make a living, and that's fine. I'm fine with that. But when you're charging that much, I'm wondering how much they actually have to charge for the test themselves and the analysis of the test. And I think it's a home test kit, so it's probably some sort of an ELISA test. They just will be like, an ELISA is like the pregnancy test that you do. You're pretty much putting the fluid on a stick, and then whether you get a line or not and compare it to a control, you know whether you have it or not. So I'm not sure whether that is measuring the antibodies or the actual RNA. But it's super easy to do if you know how to do it. But I don't think they're paying that much for it, and they're charging $150 for it. Richard, Pim, just a thanks for your time. Thank you so much, Richard. I really appreciate that. You are lovely. And thank you all. I mean, I super thank you for those of you who have been super chatting. I really do appreciate that. But all of you who are here, thank you so much for just supporting the channel and, being here, interacting with me, asking questions. It makes it actually fun to live stream. It's so much more fun than recording something. Sometimes it's cool to record something because when I lose my voice, I can just stop the recording and have some water and make gross sounds, which I don't really want to do now. Okay. Yeah, I know. It's crazy. Maybe I should start selling those tests, or all of us should do it. You can do it in wherever country you are in. So Troy has a TRX in the basement and some dumbbells. Amazing what you can do. Yeah, TRX is amazing. I used to do a lot of TRX and kettlebell training, and you can get some good workouts in with that. You can do everything with the TRX. They're amazing. Unfortunately, I left it with my ex because he probably used it more than me. I went to the gym more. I would off on testing now, unless you're really bad off. If I was given the opportunity to have the test, I would probably do it for the simple reason that I'm very curious and I would like to see if I have had it or not. So if it's a test that can show whether I have had it or not, because obviously I know that I'm not having it currently. So I'm going back to alternate day fasting. Was too nervous to do it while I had the fever. Probably a good idea. Absolutely. And that's how I'm feeling. Now I'm recovered. I'm feeling like, oh, maybe I should do some fasting now. Because I think this is also very interesting. So many of you have followed me and you know that I have a problem with my sinuses and they've been blocked for like 25 years or whatever. And I haven't had a cold in probably like 10 years or 12 years or whatever. And now I had one the other week. And what's happened is that I've got a runny nose. And for the first time in a very long time, when I can actually blow my nose, I've been able to breathe, because otherwise my nose is just blocked because it's swollen, not because it's blocked with lots of mucus. So that's such a different response. And I almost felt like, hey, why can't I have a cold every week so that my nose is just like actually excreting the shit that is in there rather than just swelling up. But unfortunately, I'm starting to go back to just being swollen, so I can't get more colds. Yay, pleasure being here. I'm glad you are here. Steve, yes, indeed. Thanks, Pim. Fascinating as always. So that was that. Unless you have any more questions, we are going to have to wrap it up. Let me know what you think. If you are you interested in hearing about fasting and growth hormones? Is that something that you want to hear about? Is that something that you think that I should be doing next weekend or not? Do you have other suggestions? Obviously, I'm going to look up a good textbook on immunity for Nesera and about the MCT oil stability for Fatnada that I couldn't really answer, but I think that it should be fine. Here we go, more things. I just don't think they have very many tests right now. I understand wanting it just to see if you've been exposed. The hobby wanted to be tested too. Yeah. No, I mean, I wouldn't go and use it if there was a shortage of tests, but if they just handed them out to everyone and there was unlimited amounts of them, sure. I've got 5 blueberry bushes I planted 6 years ago. Will produce quarts this year. Like to make a reduction and fresh jams. Cream cheese, blueberry jam in a crepe or on a low-carb crisp bread. Cream cheese. Not sure about cream cheese. Can we have cream and blueberry on a crepe? I think that's more my cup of tea. But a lot of people like cream cheese and some berry jams. It's a little bit strange to me. I love sweet, but I don't like mixing sweet and savory. And to me, cream cheese is more savory than sweet. So pineapple on a pizza is like a big no-no. Putting, pineapple or anything that is sweet in food, just no, don't do it. Or jam, for that matter. So when people are like, yeah, try chocolate covered bacon, and I'm like, oh, that must be terrible. And then they said it's really good. I've never tried it, but I'm not sure I would like to waste my bacon or chocolate that way. Anyway, it's an overreaction of the immune system. Did I miss something here? I don't know. Interesting that people with comorbidities have higher risk for COVID. This may relate to metabolic issues. Yes, I also think that when you already have an underlying condition, you have a lot of inflammation going on already. So your immune system is probably most likely not the best immune system. It's probably impaired in some sort of way and not optimal. I'm glad you're working out, Daniel. Show me your biceps. Yes to fasting and growth hormones. Cool. Necrokit, I'm going to fast soon, so info about that and losing excess skin is what I'm most interested in. Okay. Um, excess skin. You know what? I think from what I have seen and heard, people who are pretty much carnivore and do lose a lot of weight don't get that problem with excess skin, and I think it has a lot to do with autophagy as well. Even though if you were a carnivore and you were eating 24/7, you probably wouldn't get much of that going on. But when you're fasting, you will have a lot of autophagy going on, which is the what we've been talking about, the breakdown of your cells, etc. And that will go for unwanted or unneeded skin cells as well. So you might be safe. Uh, okay, more blueberry gardens. Hmm. Joint pain. Stopped all fructose. Mostly better than again, maybe a strain. Um, maybe it may be oxalates. I'm not sure how much oxalates there are in blueberries. Let me ask Dr. Google. Okay, so there seems to be some oxalates in blueberries. They're not classified as low oxalate anyway, so it could be that. I don't know. Try it. Take it with some citric acid and see what happens. Many thanks. You have done a lot of work. Well, thank you. Yes, I quite enjoy doing this work though. It took me many hours to put this presentation together and just double checking some facts. And to be honest, it was a few years since I was graduating. So when you're not using your knowledge, you kind of, how was it? Was it this way or was it that way around? So, but it was great fun actually. So it was great to share it with you, and hopefully you learned something interesting. Chocolate and bacon gross as fuck. Yeah, yeah. I don't think that's really what I want to do. Okay, so that was the last comment. So again, be really quick with your comments. Other than that, thank you so much for being here. I do appreciate you. And since at least one person wants to hear about growth hormones and fasting next week, I'll probably be doing that. Yes, citric acid, good, good. Thanks, Pim. You can try that, see what happens. Um, Necrocrit, I already have some excess skin from losing weight on keto. This is why I'm so nervous about losing more weight. Okay, but try fasting and monitor it and see what's happening, because it might be because from what you said, you're not really been able to fast very well because you've not been feeling well doing that. So maybe you just need to do that. You can also try to, I mean, this goes, I don't know how you react on to other foods, or I know you were eating blueberries, but if you can eat something else than protein, just a small amount. So you do like a protein sparing, like a modified fast type of diet, but more carbohydrates and fats only for like a day or two, you can get autophagy happening that way. Now, I'm not saying that might be ideal for you because only you know how you react to those kind of foods. And if I remember it right, you're a carnivore for a reason. But if there are any some sort of foods that you can eat that are not proteins, you can try that to just get the autophagy going and see what's happening that way without actually doing a real fast. Kirinsky, thank you so much for another super chat. Mwah. Thanks for the live stream. We'll try to tune in for more of them, and I hope you go on to do the PhD one day. You really should. Science needs bright minds like yours. Thank you. I'm not sure. I mean, I've always said I don't want to do a PhD because you're literally committing to doing the same thing for 4 years, and it can be quite soul destroying, I think. But if the right project and the right, opportunity presented itself, sure, might consider it. But PhDs don't, they don't grow in your backyard. You usually have to fight for them, and it would have to be something that I really feel like 100% I'm interested in this. Shell, thank you, and thank you, Gung Fu. Nesra likes growth hormones and fasting as well. Nice picture. We're in a bower. Thank you. Okay, cool. Danny likes it. Thank you, Karinsky, for your donation to PIM. Yes, thank you again. Growth hormone. Here are boosters claiming 700% increase versus placebo. Think placebo is literally sugar pills, which killed natural growth hormone release rather than the subs doing much of anything. Okay, cool. I'm 1 year carnivore now. This month, I think I feel better than I was at 6 months ago. Yeah. Well, that's a good thing. It's going the right way. Yes, mouth fasting. Click the like button. So, for those of you who want to support me in any other way than donations, share the videos, click the like buttons, make a fuss of it. That makes everything grow, etc. And I'm happy. You're happy. Everyone's happy. I think I'm happy because it's sunny outside, and this afternoon I'm gonna go and get some more sun. Pim, you sound like Freeman Dyson when talking a bit about PhDs. Who the hell is Freeman Dyson? I have to write that down because I have no clue who that is. Okay. Well, I'm glad that you think fasting is an option. Absolutely. Do you do OMAD at all? Thomas, thank you, Pim. Excellent broadcast. The idea of growth hormone and fasting sounds spectacular. Cool. I'm glad you like it. So now we've got 5 or 6 people that want to hear about that. So that's cool. Thanks for the stream, Pim. Thanks, Necrokitty. Scientist doesn't have attention span for them. It's not that I don't have attention span. It's that they don't have. I always like the opportunity to change and do something else if I'm getting bored with what I'm doing. So maybe that's what that depends. It's not attention span per se, but the thing with a PhD is that it's very attractive because you get to do something that is interesting, but it also involves a lot of reading of boring research articles. It's not necessarily always my favorite thing to do. I like to skim them through and read the interesting parts. And then it's a lot of writing, which I sometimes like doing, but it can be a little bit overwhelming and hard to structure, etc. And there are lots of parts of it that that I don't necessarily like. Jesus. So, I think this is a sign that I really shouldn't be talking more. I can't even. What's going on here? I can't get the comments up now. I don't know if my internet has bugged out. Can you guys still hear me and see me? Oh, here we go. Now it works again. Fabudel I can't even say that. I'm fasting for 3 days next week. It's a regular fortnight thing. That's good. I think that's really, really good. I had the intention of having a 3-day fast every month and then do some 24, maybe 48 thrown in every here and there, and maybe do OMAD or 2MAD. I've been mostly successful with my OMAD and 2MADs. It hasn't gone very well with the fasting. I've been doing a 48-hour fast maybe a month ago now. So I was supposed to do it again on the Friday when I actually got sick. So I just broke my fast after about 24 hours. So it's time for me to. There's definitely something going on with the stream here. So it's definitely time for me as well to do a fast. Maybe this week or maybe next weekend. I'm pretty much working on my own, so I'm not that subjected to other people's pathogens. So yeah, okay. Things are not going well with the stream, so if you can still hear me, if I'm still online, it looks like it's at least recording. I will see you again next weekend, or you will see me sometime during the week, whether I'm putting up 2 videos as usual or just 1. Um, okay, so I'll see you then. Well, thank you so much for being here. Take care and have a lovely day. Bye.